Hi, so in this video we discuss LeetCode problem 959 regions card by slashes. So an n cross n grid is composed of 1 cross 1 squares where each 1 cross 1 square consists of a forward slash, backslash or empty, right, or a blank space. These characters divide the square into contiguous regions. Given the grid represented as a string array, return the number of regions. Note that backslash character is escaped, so we have added a backslash at the front, right? So for this example one, like here actually the input grid is like first is empty, then this is this. Similarly for this is actually this, and this is actually empty, right? So to understand this, so this is actually empty, right? And here actually this is actually connected. So suppose this is actually connected, right? So these edges are not present actually. So this is actually the this grid, right? So this is actually the actual input grid. So how many actually regions are here actually? One region here, one here, and there is two, because this actually cut the diagonal across the diagonal, right? So there are actually two regions, so that's why the answer is 2. Okay, so for this example 2, there actually is, initially this is actually empty, that's why there is no here actually no edges are there, and the second space is actually they have this. Okay, next is both are empty. Okay, so how many actually region are there? There is only one region, this whole actually one region, right? So for example 3, you will understand here actually clearly actually. So here actually the input grid is forward slash, this actually forward slash, then one backslash, right? And for the next row, one backslash, then this is forward slash, right? So how many actually regions are here actually? One region, this is actually disconnected. For this actually, this is the second region, this is actually the second region, this is the third region, this is the fourth region, and this is the fifth region, right? So that's why answer is 5. Right? So here actually how can actually solve this? Like by using disjoint set union, we can actually do this. How actually? So just share this. So let's take example 3. So suppose this is the point. I suppose this is 0, 1, 2. This is actually 2, 3. This is actually 4. This is 5, 6, 7, 8. This is actually our point nodes are in the graph. Okay, suppose just with respect to the graph, I am just explaining. Okay, so here actually how many actually nodes are here in this graph? Here actually 3. So 3 into 3, so 9 nodes are here. Okay, so we initially what is actually initial graph? Initial graph is before we are going to the input, the graph will be look like this: 0, 1, 2, 3, 4 will not be connected, 5 will be connected, 6, 7, and this is 8, right? So here actually this graph will be connected, this graph is connected, means 0, 1, 2, 5, 8, 7, 6, 3, 0. These all are connected, right, initially. And 4 except 4 actually it is alone, right? Now whenever we're getting this processing the input string, okay, what you're getting? We're getting a forward slash. Forward slash means what? This is connecting which nodes? This is connecting, forward slash connecting from this to this node, these two nodes. So what is the two nodes? Two nodes are here actually 3 and 1, right? It's connecting node 3 and node 1. Got it? So initially our only one region was present, was there, right? Now we are connecting these two. So what is happening? This actually create two region. One region here and this is the second region, right? Now next string is backslash. What is the it's connecting 1 and 5. So we are going to connect 1 and 5, right? So you actually check, this was actually the previous region, the second region was this, right? Now what's happening? We are just cutting this region by this. So what happening? This actually is already the second region. Here actually creating a new region 3, right? So for the next string, we are getting a backslash. What is connecting the node? 3 and 7. So 3 and 7 will be connected. Initially what happened? What was the region 2? Region 2 was this. Now we are just dividing this. So what is happening here? Happening is that this is creating a new region. So this is actually fourth region, right? This is actually fourth. Now next string is a backslash. You are connecting this node 5 and 7. So whenever connecting node 5 and 7, what is happening? To the region left was before connecting this node 5 and 7, what's happening? There is only one region 2. Now we are dividing this. So what happening? 2 will remain this, okay? 2 will just be this region. Now we are creating a new region by dividing this. So what's happening? This is actually new region 5. Got it? That's why finally our answer is 5. So initially what we are doing, we will find how many actually nodes are there in our graph. So how actually I can do? So how many actually row are here actually? Input 2 row are here, and they mentioned that the grid should be n cross n. So 2 row are here. So if 2 row we have given, so how many actually row it's connecting? So it's first row will mention what? It will connect 0 and 1, this 0 and 1, and the second row will connect 1 and 2. Got it? So that's why 3 actually row are present in the actual grid, the matrix, right? Means this actually 0, 1, 2. What we are doing? We are just saying that this is actually connecting or this actually are connecting. Got it? In this way. So we are saying that this is we are connecting. So 0, 1, 2. Sorry, this row will not present. So just go to the another 1, 2. So this means we are connecting this or this or this or this, right? Got it? So how many actually nodes are present actually? N plus 1 into n plus 1, because this is a square matrix. They have mentioned that n cross n will be given. So I have found out that why n plus 1 for each row. So that's why the total number of nodes will be n plus 1 into n plus 1. Got it? This is a total number of nodes. Now initially all nodes are disconnected, right? So initially what nodes will be connected before going to process the string, input string? This actually connected like 0, then 1, 2, then 3, 5, 6 and 8. This only will connect it because this is actually our input matrix actually. Here upon this matrix we will actually place all the strings, right? So what I will do, this we will connect all this node like 0, 1 or 2 or 5 or 8 or 6 or 3 or 0. Got it? Now what I will do, whenever we are processing anything, like first we get this forward slash. So what we'll do, we will know that okay, connecting node is 1 and 3. Okay, then and I know initially that total number of region is 1, because this is the only one region. Okay, now what's happening here? Now we are trying to connect this 1 and 3, this 1 and 3. Then I will check, is this 1 and 3 already connected? Yes, this is already connected, right? How can I actually find out? By using disjoint set union find, we actually find out that what is the parent actual final parent of node 1 and what is the final parent of node 3. Then I'll check, okay, both are actually parent to 0. That means what? 1 and 3 already connected. Okay, now what you're doing, we are just doing that, we are again connecting this. So we are creating a circle, like this is actually the, suppose the graph actually, anything, structure can be anything. Okay, now we are saying that this node, we are trying to connect this node, this two node. Now I am checking what is the final parent of this node and what is the final parent of this node. Suppose U and V. Then I found that both parent of this node, two nodes are same. That means what? Already there is a path to, means both are connected already. Now we are going to connect this. That means what? We are just we are completing a circle or something, a region. Just complete the boundary. That means what? We are creating two region, one new region here actually. This is the one region, this is the second region. Got it? So whenever I found anything that U and V, both parent are same. Now we are trying to connect these two. That means what? Regions will be increased by 1. Got it? This is actually the logic. And suppose this is actually again a region. Suppose this is the 4, and there is an edge connecting from 4 to 2. 4 to 2. Okay. So what is the parent of 4? Parent of 4 will be 4, because this is disconnected from others node. Now what is the parent of 2? Parent of 2 is actually 0. Final, suppose all are connected to final, we have map actually 0. Okay. Now both are actually different. Parent 1 and parent 2 both are different. Now if we connect these two, we will create any new region? No. Why? Because suppose we are randomly doing anything actually. Suppose this is our structure, and suppose we are saying that, okay, connect these two. This will not create a new region. When we create a new region, whenever we're creating a new boundary. Boundary means what? Both are already connected in somehow. Okay. Now we are saying that we will connect these two also. Now what we are complete a circle actually. That's time I will create a new region, right? So that's the logic. So just go to actually code. So this is actually the given function regions by slashes, and we will get the input string. Okay, initially how many actually row are present? N, suppose. So how many actually actual row are there? N plus 1, and similarly for column will be n plus 1. So that's why I will find what is the dot. Dot means number of nodes. Okay, this is n plus 1. So I have actually taken two vector, one for parent, one for ranking. You already know, like we can actually do the disjoint set union find by rank also, right, to optimize this. So that's why I'm using here also rank. Okay, so what is the size? What is the size? Size will be 0 to n plus 1 into n plus 1. Got it? That's a dot into dot. Got it? Now initially our number of region will be 1. We know already that, because this is actually our input matrix. Got it? Now we are actually initialize all the things, like initially all the nodes will be disconnected. So that's why parent of I will be I and rank of I will be 1. Got it? And I have initialized for all, means 0 to n plus 1 into n plus 1. Okay. Now what to do? We are connecting this matrix actually, the boundary actually, actual boundary, because otherwise it will be out of bound if we do anything here actually. So that's why you are connecting this. Okay. Now how actually you do? Like you can actually one observation, like here actually you are any point for this I is equal to 0, right? I is equal to 0, and any things for this column is j is equal to 0, right? And anything in this row value will be in right, means dot minus 1. Similarly for any point, any node present on this side, is j will be in dot minus 1. Got the logic? So that's why I'm just traversing all the things. All the things means I know already that what is the matrix size. So I'm just traversing I is equal to 0, I less than dot, and similarly for j is equal to 0, j less than dot. We are checking if I is equal to 0 or j is equal to 0 or I is equal to dot minus 1 or j is equal to dot minus 1. So any point lying in between. So I will actually find out this. So that time what I'll do, I will find out actual node number. So how actually find the actual node number? So this actually node number is 0, this is 1, this is 2, this is 3, 4, 5, 6, 7, 8. Okay. So for 8, suppose what is the row number? Row number is 0, 1, 2, 2, 0, 1, 2, 2, 2. Okay. So I know that in each row 3 elements are present, right? So what is the sequence of this? Like 3 into 2, like I know above on this above the row number 2 how many actually element are present. First 0th row will be 3 element, again first row will be 3 element. Now so how many actually how many nodes are there on before this row? 3 into 2, because each row have 3 element and there are 2 row above this. And how many actually column are present in the left side of this? How many column? This is the 1 column, this is the 2 column, so 2 column are there. So this actually the 2. So sequence number 3 into 2 is 6 plus 2, it will be 8. Got it? That's actually 8. Understood, right? Logic. So what actually I'm doing? I am doing row number of the current node, current position we want to, and how many actually dot are there for in each row plus column. Got the logic? This actually row number is 2 and column number is this 2, and here actually dot will be 3, right? So you can actually check here actually cell number will be I into dot. I means the current row number and j is the current column number, and how many elements are present in the each row dot, right? So I am checking whenever the cell number is not equal to 0, that I am just actually connecting these two nodes. Okay, like 0 is already connected, so I am just connecting with 0 and 1, then 0 and 2, 0 and 3, 0 and 6 in this way. Got it? That's why I'm connecting this 0 and all other. 0 and 0 doesn't mean anything. Okay, that's why I just added a condition that if cell number is not equal to 0, that time you should add this. Okay. Now what I'm doing, I actually initialize the matrix which is connected this the region 1. No, only one region is present, right? Now what I'm doing, I'm just traversing the input string. What is this value can be present on this input string? One can be forward slash, one can be backslash, others can be blank space, right? So I'm just traversing this and I'm checking if it is a forward slash, means what? It is connecting, right? This is actually the suppose u and this is the v. What will be the value of u? So value will be u, this is actually I comma j, right? So value of u will be what? I into dot into j plus 1, because this is actually the j I am here actually currently. So this is forward slash means what? This will actually tilde to this next column and to the next column, row will be same. That's why I into dot plus j plus 1. That's why u. Alright, column will be shifted to this. I am here actually in this column. I am processing this column actually, but I am saying okay, this is a forward slash. But that means what? Means I am suppose here actually. So I am actually 0, 0. So whenever seeing any forward slash, that means what? Row will be same I, but j will be j plus 1. I am initially I comma j. Got it? That's why I into dot the j and plus at j plus 1. This is actually the cell number of that. This u actual node number. And what is the cell 2? Cell 2 will be v. V will be what? I plus 1, because row will be increased in the bottom, right? One row will be increased, I plus 1 into dot plus j, because these are same in the same column. Got it? And then I will actually just add this edge u and v. Got it? Else I can, what is the input can be? input can be backslash. Then what will happen? I will just check that what is the cell 1. Cell 1 means this is actually U, this is actually V. That time what happened? U will be the same row and same column because we are in the same position. That's why I into dot plus j. But V will be what happened? This actually point to the next column. So I plus 1 will be the same and j plus 1, right? To here actually for the backslash. Then what are we doing? I plus 1 into dot and j plus 1. Got it? Then I will actually union of these two node. Okay. Then what will happen? I will just return the count. Okay. So just go to the actually function or whatever doing in the union. So union, what I will get? I will get two node U and V, right? Then I will check what is the parent of this two node. So this is parent 1, this is parent 2. Then how actually I getting this parent? So I'm calling this helper function find, and we're passing the current node number U. So I'll check whenever we have the current node presenting to this node, initial any node, like 0 will be present to 0, right? So that time this is actually the ultimate parent, because suppose this node is 1 is parent of 1 is actually 0 and 0 parent is 0. That means what? 1 is connected to 0 and 0 is the parent ultimate. 0 is not connected to any other node, right? So that's why the ultimate parent will be 0. So that's why check whenever the parent of x is equal to x, that time return the x. Okay. Else what happen? Like for whenever coming to this node 1, I'll check. I'm find that okay 1 not equal to 0 because parent of 1 is equal to 0. So what I'll do? I'll just go to the parent of this parent of 0. Okay. Then what will happen? I will just assign this to optimize this for the next time. Okay. And return temp. What I will get? I will get actually 0. What is the logic? In this actually I will find the ultimate parent of any node. So in this actually I will find the parent 1, parent 2 of this two node. I will check. If it is not the same, parent 1 not equal to P2, that means what? This region not connected, so it doesn't mean we are not creating any new region. That's why whenever the parent 1 and parent 2 both are same, that means what? We will come to this else condition, else block, and I will increase the count. Got it? Initially count is initially 1, and whenever increase, this will be actually 2 in this way. So whenever this is not same, then what I will do? We'll just optimize this because next time it can be happen. So you know that by using rank, actually we can actually optimize this. So I'll check what is the rank of the parent 1 and what is the rank of parent 2. Okay. Then if the rank of parent 1 is greater than of rank of parent 2, then what will I will just attach P2 to P1. That's why parent of P2 like L1 will be LX. Got it? What will actually do? We just actually optimize. You already know, right? That how actually optimize this. Like in this tree, I have actually 3 nodes, and suppose in this subset, in this set I have actually 2 nodes. So rank will be here to 2, and here it will be 3. Okay. Then should I actually merge these 2 into these 3 nodes? No. That time actually take times like what is the depth of this? Like I will depth will 1 2, like 1 2 3, right? And what if I actually merge these 2, and if I merge these 2 actually, then what will the depth? 1 2. Got it? In this way. Now I'll check what is actually number of rank actually present. So I'll check whichever the rank actually less, I will attach this to the more number, right? So that's why if it is less, that's why I am just attaching. Else if what will happen? Parent 1 of parent 2 rank of is greater than parent 2 parent 1. So one will how actually attached? I will attach P1 to P2. That's why parent of LX will be LY. Got it? And else what happened? Both the rank is same. Rank 1 and rank 2 both are same. Then what I will do? I will just actually I can actually attach any node to any parent node. So that's why I'm just here actually I'm just doing parent of P1 will be attaching to P2. Okay, and rank of L1 will be increased by, like parent 2 will be increased by +1, right? Because we are attaching a new thing, like these are actually both are same. Then I can actually rank with both are same actually 2 2. So what will happen? I will just actually attach any node So that's why the rank will be here actually 3 actually currently. Got it? In this will optimize this. Got it? And also understand the logic, right? That how actually disjoint said union actually here actually help us. Thank you.